Hello guys, my name is Craig and welcome to Peri Solutions. In today's video, we're going to be looking at factorization of determinants. But before we start, please make sure that if you're new to my channel, you hit the subscribe button and turn on the notification bell so that you don't miss out on any new videos. Okay, so to start off, we need to know that for factorization of determinants, the easier way to find the factors of a determinant is to use the rules for manipulating determinants, and I shall put the link above on how to use the rules of manipulation of determinants. Right, so I shall attempt these questions and simply show you how we can factorize determinants. Okay, so for number one, we're being asked to factorize a, b, c, a squared, b squared, c squared, then a cubed, b cubed, c cubed. Okay, so first thing is that we know that we've got a common factor here, which is a, b, c. So if we factor out a, b, c, we get 1 here, 1, 1. Then we get a, b, c. Then we get a squared, b squared, c squared. Like that. Okay? And then now, from this, what we can do is that for us to find this, the determinant for this, applying the laws of manipulation of determinants, we can make these elements zeros. So we can rewrite column 2, right? We can rewrite column 2. So let me say column 2. We can rewrite it as column 1 minus column 2, right? Which will give us A, B, C, right? Column 1 remains unchanged. Then column 2 is saying 1 minus 1, right? So column 2 is supposed to be column 2 minus column 1. So column 2 minus column 1. So 1 minus 1, 0. Then B minus A. Then B squared minus A squared. Then column 3 as well, we can rewrite it as column 3 minus column 1. So if we say column 3 minus column 1 is saying 1 minus 1, that's a 0. Then C minus A, then C squared minus A squared. Right, so if we break this down step by step, from column 2 we see that B minus A is a common factor, yeah? So we can say A, B, C, then we factor out B minus A. B minus A is a common factor. Why? Because we know B squared minus A squared is difference of 2 squares. So this is B minus A, B plus A. So that makes B minus A common there. Then we now have, so B minus A is common there, and from column 2, then from column 3, same situation, C minus A is common. Why? Because C squared minus A squared is C minus A times C plus A. So we can actually factor out C minus A. Right, so that we now have 1, 0, 0. Then A, so B minus A to B minus A, we now have 1. Then C minus A to C minus A, we now have 1. Then this is just A squared. And this, B minus A into B squared minus A squared, you now get B plus A. Then C minus A into C squared minus A squared, you now get C plus A. So we're now simplifying the determinant of this. But we know that since these are zeros, this is now A, B, C times B minus A, C minus A, right? C minus A. Then the determinant of 1 times 1, right? So 1 times, if we close this and that, you're finding the determinant for that. So 1, 1, B plus A, C plus A. Right, so if we continue with our calculation, we're saying that A, B, C, right? B minus A, C minus A, multiplied by 1 times C plus A, that's your C plus A, then minus 1 times b plus a. This is just minus b minus a. So c plus a minus b minus a, right? Here I just say if it has to be minus 1 times b minus b plus a, and this is minus b minus a, which is what I've put here. So a minus a will now give you 0, which means you've got a, b, c, b minus a, c minus a. Then a minus a is 0, then that's your c minus b. Okay, so this is the vector that we get, and if we want, we can expand or we can leave it like that. But this is how we can vectorize the first question. Okay, so now I'd like to look at how we attain the second one. So allow me to erase this here. Okay, so now for the second one, we're being asked to factorize the determinant of A, B, C, B, C, A, C, A, B. So applying the laws of manipulating determinants, we can rewrite the first row, right? We can rewrite the first row as row 1 plus row 2 plus row 3. This is going to help us to establish a common factor that we can factor out. But because if our elements are like this, we don't necessarily have a common factor to factor out. But now let's see what happens if we manipulate the first row such that is that. So we're saying that first row was A plus B plus C. So A plus B plus C. Then for this one here, this is B plus C plus A, which is just A plus B plus C. Right, then for this is just C plus A plus B, which is just A plus B plus C. So now we've rewritten our first row like that. Now, the second row and the third row, this can remain unchanged. But now we see that we've got a common factor of A plus B plus C. So if you factor out A plus B plus C, right, we now have 1BC, 1CA, 1AB. Right. Now we have this. And what we can do, using the laws of manipulation of determinants, we can make these elements zeros. And to do that, it means we can rewrite column 2 as column 2 minus column 1. And we can rewrite column 3 as column 3 minus column 1. Okay? So now we're saying that A plus B plus C, right? Then column 1 we say is remaining unchanged. Right, then column 2, we're saying column 2 minus column 1. So 1 minus 1, then we get a 0. Then C minus B, then A minus C. For the second column, for the third column, 1 minus 1, we get a 0. Then A minus B, then B minus C. So this is the B, right? You write it properly. Right. So this is now B minus C. Like that. So now we say A plus B plus C times the determinant of 1, right, times 1 multiplied by the determinant of. So if we cancel that and cancel that, you're finding the determinant of what's remaining here, which is that. So find the determinant for that will be C minus B times B minus C. So C, okay, let me write it properly first. Then A minus C, then B minus C. So we're saying A plus B plus C multiplied by C minus B, or let me put square brackets. So C minus B times B minus C minus A minus B times A minus C. Like that. So this is how we can do that. So allow me to erase this top part here, that I can create space to calculate that expansion. So now we're going to expand. Right, we now have A plus B plus C, then square brackets, put the square brackets. So this is simply BC plus BC. So this is the 2BC, right? So 2BC, then minus B squared minus C squared. So minus B squared minus C squared. And then minus A times A, that's A squared. Then we've got minus B times A, that's minus AB. Then we also have A times minus C, that's minus AC. Correct? Yeah, that's correct. So we can now, and then we also have minus B times minus C, which is plus BC. Right, and then we can do that. So now if we remove these brackets here, we now have A plus B plus C, then 2BC minus B squared minus C squared, then minus A squared plus AB plus AC minus BC. Right, then minus BC plus 2BC, that will give us BC. So we've got A plus B plus C, right, multiplied by AC plus AB plus BC minus A squared minus B squared minus C squared. Like that. So this becomes the factor that we get. And of course we can multiply out if we want, or we can just leave it like that. Then the second part now requires us to find factors of A to the power of 3 plus B to the power of 3 plus C to the power of 3 minus 3BC. So now, what I'm going to do, allow me to erase this. Right. So now for this last part, if you first of all find the determinant of this using the long way, we're saying A, then determinant of AC, CA, AB minus B multiplied by the determinant of BA, CB, then plus C multiplied by the determinant of BC, CA. Right, which will be A, BC minus A squared minus B, B squared minus AC plus C, AB minus C squared. Right, so now if we multiply out, we've got ABC minus A cubed minus B cubed plus ABC plus ABC minus C cubed. So you've got ABC plus ABC plus ABC, right, this is C, which will be 3ABC, then minus A to the power of 3 minus B to the power of 3 minus C to the power of 3. Right, but we see we're required to find factors for this, but look at this. So what we can do, we have to make these positives and this negative. So if you factor out the minus 1, that will be A to the power of 3 plus B to the power of 3 plus C to the power of 3 minus 3ABC. Which simply means that this is the determinant of minus 1 of that. So we're simply saying A to the power of 3 plus B to the power of 3 plus C to the power of 3 minus 3ABC is equal to minus the determinant of A, B, C, B, C, A, and C, A, B. But we got the factors already as A plus B plus C times AC plus AB plus CB minus plus BC minus A squared minus B squared minus C squared. So we're not just adding the negative here, right, to that. So A plus B plus C, then we've got AC plus AB plus BC minus A squared minus B squared minus C squared, like that. And if we multiply this in that bracket, we've got A plus B plus C times, this becomes positives, A squared plus B squared plus C squared, and then these become negative, right? Minus BC. So this is the result that we get for the vectors of A to the power 3 plus B to the power 3 plus C to the power 3 minus 3BC. Okay, so this was looking at factorization of determinants by using the laws or the rules of manipulation of determinants. So please feel free to leave a comment, drop a like, and don't forget to subscribe. Thank you.